Hello guys, this is a short and quick stoichiometry notes. If you've never worked a stoichiometry problem before, we'll try to break it down to simple steps. All right, we'll go ahead and jump right in. This is a synthesis reaction of chlorine gas and oxygen gas to make ClO3. So of course chlorine is diatomic, Cl2, and oxygen is also diatomic, O2. And it gives you the product of ClO3. Now, of course, to balance this, we learned from last week. We look on both sides, and we see that there's a 2 and a 3 here. So let's try a 2 here, a 3 here, and of course, our chlorines are already balanced. So that's our balanced equation. Now, I like to do something called a map. So where are you? You're at 3 grams of chlorine. And where are you going? How many grams of ClO3 do you need? This is where you are, and this is where you're going. To me, that's very, very important, because in a minute, we're going to use this 1-to-2 ratio. So remember that. So let's start off with a basic conversion, 3 grams of chlorine. Remember your factor label, dimensional analysis, everywhere you want to call it. So we're going to come down here and do 35.5 times 2. I'm going to round that to 71 grams. And that equals 1 mole of Cl2. Okay, now we're ready for our what we call our mole bridge. And I'm even going to write it across here, mole bridge. This is very, very important. You can't do this problem without a balanced equation. So here you see there's a 1 for every 1 mole of Cl2. Notice it had to go on the bottom to cancel out. And that'll give you 2 moles of ClO3. Okay, what's our final unit in? It's in grams, so we're not done yet. So we're going to have to go 1 mole of anything equals its molar mass. And when you see the G, go to the PT. So we're going to type in 35.5 for chlorine plus 3 times 18 for oxygen, and we'll get 89.5 here. All right, we're ready to type in all of our numbers. This number times 2 times 3 divided by 71. And your final answer there with 3 sig figs should be 7.56 grams of ClO3. Okay, that was a gram to gram problem. You started with grams and you ended with grams. Let's try another one. So we're going to go to number 2. Notice we got a combustion reaction of butane gas. So we'll start with C4H10. And we're going to add oxygen to burn anything. And we're always making CO2 and water with any combustion reaction with hydrocarbons. So there we go. We're going to go ahead and balance this. I know enough to put a 2 here in the beginning because that would be an odd number. So we're going to try 8 here. And again, this is balancing from last week. So you should already have these skills. This is one that a lot of people forget. 16 oxygens plus 10 oxygens equals 26 oxygens. So how do I get 16 on that side? Let's add a 13 there. All right, so there's our balanced equation. Now we're ready for our map. What are we starting with here? 0.5 grams of butane gas. And what are we going to? Moles of H2O. Notice we're not at grams this time, we're at moles. So this would be a gram-mole stoichiometry problem. We're ready to go ahead and begin. We'll start our wonderful factor label. And now we're going to look up on a periodic table and see that we've got 4 times 12 plus 10. We're just going to round that to 58. And that is 1 mole of C4H10. Now we're at that magical point that we need a bridge to go from apples to oranges is what I tell students. Apples to oranges. What's our ratio? If you put your finger on it, we'll see it's 2 moles of C4H10 to 10 moles of water. Now in the last problem we kept going, but in this problem we're going to stop because look what you're asked for. Moles of water, you stop. So when you type this in, 0.5 times 10 divided by 58, I'm going to hit divided by 2. My final answer, again, 3 sig figs. Our last problem, we're going to be using atoms. So if we come down to the very bottom, we have a problem where we're going to start with atoms. But first, again, we need that balanced equation. So we got a single displacement reaction where we're taking aluminum and we're adding sodium hydroxide to it. And one of the products is going to be aluminum hydroxide. And of course, sodium gets kicked out. So I tell my students, normally if you listen closely to this equation, you'll hear it say, balance me, balance me. At least that's what I hear. Maybe it's just voices in my head. But here we go. We're going to try slapping a 3 here. Now we got 3 hydroxides, and a 3 here. We're done. All right, well this time we're starting with atoms. 10 to the 22nd atoms of aluminum, and we're going to how many grams of aluminum hydroxide. So this one may be a few more steps. So we need to really be careful here at the start. So we got 3.01 times 10 to the 22nd atoms of Al. Notice I drew a long line there. Students always hate it when I draw a long line because I know it's going to be a big problem. But if we think back to about 2 weeks ago, we remembered that atoms. What do we know about atoms? That's right, that video you watched, 6 times 10 to the 23rd. So that official number, of course, is 6.02 times 10 to the 23rd atoms. And that equals 1 mole of aluminum. Okay? Now we're ready for our bridge. We're at moles. Anytime you get to moles, you're ready for your bridge. You need 2 fingers here. 1 mole of aluminum, 1 mole of aluminum hydroxide. We got very lucky there. 1 mole of aluminum, 1 mole of AlOH3. Are we done? Well, they're asked for grams in the question. See why that road map is so important? The grams and moles, nope. So we got one more last step. And again, we know 1 mole of anything equals its molar mass. So we're going to go to the PT. When you see the G, go to the PT. We've got 1 aluminum, so that's 27 on the periodic table, 3 times 16 plus 3 times 1. So we get a molar mass here of 78 grams for aluminum hydroxide. 78 times the big number divided by 6.02 times 10 to the 23rd will give us our answer. So let's type that in. Don't forget second EE. And our final answer is 3.9 grams. Well, and if we made that 3 sig figs, let's add a 0 there. 3.9 grams of aluminum hydroxide. And that 3 is on the outside of the parentheses there. Sorry about that. All right. With these 3 examples, I believe you will be successful in working the 7 problems I've given you for this week's homework. So again, each problem should take somewhere between 4 and 6 minutes. So take your time, maybe do 2 or 3 each day, and it won't be such a burden. I hope you have a great week.